I would like to make a comment about theorem 4.21. Don't need to prove that because it follows right after the theorem 4.20. And what are the C-mediums? C-mediums, they are the isogonal conjugates of the mediums, right? And then we know the mediums of a triangle are concurrent, so we already know the mediums of a triangle concurrent. Therefore, they're isogonal conjugates, which means the C-mediums, they are also concurrent. So that's just a quick comment about this theorem. It comes from theorem 4.20. We will prove theorem 4.22. Theorem says the C-medium from one vertex of a triangle bisect any segment antiparallel to the opposite side of the triangle. If I have to identify what I want to prove, here's the subject of the statement, here's the verb of the statement, and then bisect the segment antiparallel to the opposite side. So this is the object. So that's what we want to prove. To make sense of this statement, let's begin with a triangle ABC, ABC. And then one vertex, I'm going to pick a vertex A. It says the C-medium, therefore I'm going to construct the medium through this vertex A, which is A prime in this case. This is the medium. And A double prime will be its C-medium. Now we want to, it says any segment antiparallel, so we need to find a segment that's antiparallel to the opposite side, which is the BC. How do we find the antiparallel segment? So first of all, we just find a circle passing through segment B and C. How do we do that? There are infinitely many circles that are passing through the points B and C. So you simply find the perpendicular bisector and then center at pick a point on the perpendicular bisector, center at this point and radius from this point to B, and then you draw a circle. There are infinitely many circles because you can take different centers, right? So as long as you pick a circle that can intersect side AC and AB, then you can find two intersections. And this is a cyclic quadrilateral, and therefore this line segment DE in this case is at one antiparallel segment to BC. Of course, if you make a larger triangle, then your segment will be different, right? But anyway, this is how I kind of explain where this is from, the antiparallel segment. So go back to read the statement. It says this C-medium, which is A prime, A double prime, bisect this antiparallel segment to BC. That's what we want to say. This guy bisect this segment, which means I want to prove DF, where F is the intersection of this C-medium and this anti-parallel segment. So which means DF over FE is equal to 1. That's what I try to prove. So now allow me to write down what's given, what's unknown, what's to be proved, right? Let A prime be the medium and A double prime be the C-medium. And DE, segment DE is a segment antiparallel to the opposite sides, which is the CB. Well, please note that because this is an anti-parallel. Well, just make sure that anti-parallel segment means it's the opposite side of a cyclic quadrilateral. So that's why there's a circle here. Just try to help you understand where this segment is from. So this usually doesn't have to be in the proof, but try to help you understand. In other words, CDEB, this guy, this quadrilateral is a cyclic quadrilateral. So that you know what anti-parallel means. All right, what do we want to show? We want to show that this symmedian bisects this segment. That means DF over FE is equal to 1. That's what we want to show. How do we show it? It's actually just a couple steps. But of course, we need to have some prerequisites. The first result that we need to use is the notes problem number 4. Let's quickly review what that result tells us. So if you have a triangle, and then if you have a segment, say in AD, that intersects the opposite sides, then you know that CD over DB is equal to AC times the sine of this corresponding angle, the angle opposite to this corresponding segment CD, over the AB times the sine of that angle. These results basically links the ratio of these two segments to the ratio of the two sides. So that's the significance of that result. Another result that we will need is actually the theorem 4.9. Let me help you recall what that is. Theorem 4.9 says if AB is tangent to this circle, ACD is a secant intersecting the circle at points C and D. Theorem 4.9 says AB squared, the square of this tangent, is equal to AC times AD. That's what theorem 4.9 says. Obviously, if I have another different secant, which is AEF in this case, AB squared should be equal to AE times AF. I just applied the theorem 4.9 again, right? Which tells you, isn't that the right-hand side both they're equal to AB squared? So therefore, I can conclude that AC times, oops, there's a little typo here. AC times AD, right? AC times AD should be equal to AE times EF. So that's another result that we need. So basically, if you look at this shape, I can, according to this theory, according to what we just discussed, we will know AD times AC equals AE times AB. That's what it says. So this actually comes from theorem 4.9. So I'll begin with that. So by theorem 4.9, right? Explained above, we do know that look at this triangle look at this circle. Look at this circle. The circle passing through D and E. We do know there's a circle because it's an anti-parallel segment. That means this is a cyclic quadrilateral. It must be inscribed by a circle. So we say AD times AC should be equal to AE times AB. Well, why do I need that? I'm going to explain that quickly. I will rewrite this equation into the following ratio. AD over AE equals AB over AC. By rearranging, divide both sides by AE and divide both sides by AC. That's what we get. Take a look at the left side AD over AE. So do you see this is the side of this AD is this side of this smaller triangle, and AE is the other side of this smaller triangle. You know, we have a way to link the sides to the opposite the opposite sides, right? So we are going to do that, but this is the first step. And take a look at the right hand side, AB and AC. So AB is this side of this bigger triangle, AC is this side of the bigger triangle. So that's a good start. Now what we are going to do is, I have to move up my, okay. So now we're going to do some substitution here. Take a look at what our target. Our target is dF over FE. So I'll begin with that. dF over FE equals, okay, dF is this guy, FE is this guy. So according to the problem number 4, it is AD times sine of the corresponding angle, this angle, which is ADF, right? Actually DAF, not the ADF. So it's DAF. Over AE times the sine of EAF. So this time EAF, this segment is corresponding to EAF. Now we just do a sequence of the substitution, which is equal to AB AC. Well, I hope that you see what the substitution is going on. This is really coming from here. AD over AE is actually equal to AB over AC. So that's what's going on there. Sine of DAF over sine of EAF. Okay, now this is equal to ABAC here, and I'm gonna claim that sine of, keep in mind, sine angle DAF is actually equal to angle BAA prime. Let me show you this. I'm gonna delete these little drawings there. So what I'm saying here is DAF, which is this angle, should be equal to this angle. Why? Because this is the symmedium of the medium, right? So therefore these two angles have to be equal. That's the reason. As AA prime is symmedium of AA double prime is symmedium. So therefore I'll do the substitution here, BAA prime. And also EAF is equal to angle of CAA prime. This means this EAF, which is this guy. I'll highlight that in. This angle should be equal to this angle, basically. That's what I'm saying. Hopefully you're convinced. CAA prime. And now if you look at this big triangle, AB times this angle BAA prime, AA prime, over AC times sine of this angle, right? So isn't that, according to the problem number 4 we just proved, it's equal to BA prime over A prime C. It's this corresponding side is this and this. So therefore, and you do know A prime is midpoint, and therefore this ratio is 1. That's exactly what we want to prove. I'll try to label the very last. So look at these true angles. BAA prime is this angle, and CAA prime is this angle. So we are applying the notes problem number 4 to the very last step.